A convex quadrilateral has area 30 and side lengths 5, 6, 9, and 7 in that order. Denote by theta the measure of the acute angle formed by the diagonals of that quadrilateral. Then tan theta can be written in the form m over n, where m and n are relatively prime positive integers. We have a convex quadrilateral here with area 30 and side lengths 5, 6, 9, and 7, and we want to know what the acute angle is that's formed by the diagonals of that quadrilateral. There we go, we have the acute angle theta formed by the diagonals of the quadrilateral, and we want to find the value of tan theta, which is equal to sine theta over cosine theta. To find sine theta, we can do so by using the four triangles that the diagonals split up the quadrilateral into. And that's especially useful since we can sum up the areas of the four triangles, and then we have to get 30 because that's the area of the quadrilateral. So let's label these segments A, B, C, and D, and then we can use that along with theta to get some law of sines area formula relationships. We know that the area of this first triangle is 1/2 AB sine pi minus theta. The area of the second triangle is 1/2 BC sine theta. The area of the third is 1/2 CD sine pi minus theta. And then the area of the fourth is 1/2 dA sine theta. But since sine pi minus theta is equal to sine theta, we can just factor out a 1/2 sine theta. And this becomes 1/2 sine theta times AB plus BC plus CD plus DA, and that's equal to 30. So sine theta times AB plus BC plus CD plus DA, which is just A plus C times B plus D, is equal to 60. And so we know that sine theta equals 60 over A plus C times B plus D. And now to get cosine theta, we can use the law of cosines on each of the four triangles now, with A, B, C, D, and the angle theta. So we get, for the first triangle, we have A squared plus B squared minus 2AB cosine pi minus theta is equal to 5 squared, which is 25. For the second one, we have B squared plus C squared minus 2BC cosine theta is equal to 6 squared, and that's 36. Now similarly for the third one, we can do C squared plus D squared minus 2CD cosine pi minus theta is equal to 9 squared, which is 81. And for the fourth one, we have to do D squared plus A squared minus 2dA cosine just theta this time equals 49. Now, cosine of pi minus theta is negative cosine theta, so we can do this, but we just have to turn this negative into a plus sign. So now what do? Well, we can add the first and third equations and then subtract the second plus the fourth. We have A squared plus B squared plus C squared plus D squared, and then minus B squared plus C squared plus D squared plus A squared. But that's nothing because they're the same thing. They're both A squared plus B squared plus C squared plus D squared. Now, if we add and subtract the second parts, we get 2AB plus 2CD. And then minus of minus is plus, so it will be plus 2BC plus 2DA. And all that times cosine theta is equal to 25 plus 81 minus 36 plus 49. And that's equal to 106 minus 85, which is 21. So this expression inside the parentheses, that's 2 times A plus C times B plus D. So 2 times A plus C times B plus D cosine theta is 21. And so cosine theta is equal to 21 over 2 divided by A plus C times B plus D. Now, if we want to divide these two, which is what tan theta is, we get 60 divided by 21 over 2. And that's equal to 120 over 21, which is equal to 40 over 7. And it can be written in the form m over n, where m and n are relatively prime positive integers. Here m is 40 and n is 7. What is m plus n? That's 40 plus 7. It is 47. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.